This is what I'm saying. I'm going to connect a speaker here. 8 ohms. So RC is how much? 12K. RL is how much? 8. Divided by 52 plus 100. What is 12,000 in parallel with 8? 7.9? 7.9. Product over sum. Do a product over sum of 12,000 with 8. Is it about 8? We'll say this. How's that? Elahe. 53? No.
It's like 7.9.
7.9?
I didn't even count it out. Yeah, 8.
About 8. Divided by 152. So what's 8 divided by 152? Point something?
0.05.
0.05. That's okay. Not a problem. So it says that now my gain, which I started out with a gain of 5, with no RL, no CV. Then I had a gain of 79 with CV. Then I had a gain of, what, 36 by having a 10K load. But what if that load was 8 ohms? My gain is a negative gain. It's even less than 1, isn't it? And any gain less than 1 is my signal with, instead of getting bigger, is now doing what? Shrinking. So that's called attenuation. Opposite of amplification is what? Attenuation. Attenuating means that the signal just died. Okay? So, and this is an amplifier circuit. Instead of boosting my signal, what is it doing? It's making the signal small. So that's why I'm going to take that common emitter amplifier circuit and connect a common collector amplifier circuit, which is what we're going to do in our next class, okay, which is this guy here, Notes 14. If you didn't pick up a copy of Notes 14, get it? But that's my second stage of the two-stage amplifier circuit, and it's not going to make my signal small. It's going to keep that signal the same as 1.8. 1.8 going in, 1.8 coming out. Okay? So that's what we're going to talk about next class. So that's the whole point. And then, so go have a look at Notes 14, everybody. Have a look at Notes 14. Anybody need a copy of 14? Everybody's got it? Okay. Have a look at Notes 14. See where it says RL? See where it says RL on page 1 of Notes 14? Around RL, can you draw this box? So where it's RL, can you draw a box and show a speaker there? So do this. And write down 8 ohms there. Okay, that's what we're going to do with what's called a common collector amplifier circuit. Okay, so the example on page 4 of Notes 14. Go to page 4 of Notes 14. This is a preview. This is a preview of what we're going to do. On page 4 of notes 14, in the example, what does it say the load to be? Line 2. 8 ohm speaker. Okay? No, of course I'll give you that. Most speakers, 99% of the speakers are 8 ohms, but there are 4 ohm speakers, there are 12 ohm speakers, there are 16 ohm speakers. But they're not 10,000 ohms. They are low resistance. Okay? Okay, so that's our, so that's what happens there. Now, I've got a few minutes before we write a quiz to take you on page 6. So go to page 6 now, everybody. Page 6. 13. Notes 13, page 6. Notes 13, page 6. Are you on page 6? The common emitter amplifier circuit, AC equivalent circuit. Okay? With these amplifiers, the math for this circuit, or the way to analyze an amplifier circuit is to have a couple of assumptions or rules of thumbs or behaviors of the circuit. So right at the top of the page, what does it say? For AC analysis, the capacitors C1, C2, C3 are what? Shorted, which means closed switch, right? Write down closed switch. Beside the word short. Closed switch. So show this. Okay, closed switch. The second behavior of an amplifier circuit is that the DC source is replaced by a ground. What does that mean? What it means is this. This is my DC source. Does everybody see that my DC supply is here? This is replaced with a ground. This AC signal here feels that this guy here is like this. It feels that the DC supply is at ground potential. So, what I want you to do is draw a little circuit beside figure 8 on the right side. See where it says figure 8? Draw a little circuit there. Let's draw this.